All right, let's go. We will organize my day. Now, interestingly enough, we have I got this automated thing going on my calendar, which creates all these calendar events. And the thought is that I should be able to understand when I can learn the best, when I can do stuff other than learning, and when I can learn again. So peaks are, where I can learn, but dips are maybe where I do my workouts, my food, but not until 4 in the afternoon, I don't think, right? So there's a little bit of a iffiness to this. But I will definitely be following, say, wind down at 8 p.m. So we'll see. We'll try and follow some of this during the day today. I still need to buy some stuff at some point, so I might do that in the afternoon. We need to do these practice problems. Oh, shoot. I keep on forgetting. I wanted to see what the practice problems were like as well. And before this stream started. So at some point I might pause the stream and come back again, right? So that, because I have to be kind of offline in a sense to do this other practice exam. So I will partially do that. Jamil, no, this isn't my scheduler app. This is Things 3. I'm just scheduling my day. Alright, the scheduler app is probably gonna happen later. I'm gonna do a bit of that later. We'll need to have some lunch. Now, I did go for a walk already this morning, so that can be ticked off. I should go to the gym. Now lunch, we're gonna have to make lunch. Hello Matt. Let's see. Oh, all good, Jamil. All good, Jamil. That's glad to hear. Glad to hear, you know? Awesome. So all of these lectures is not likely to all be done. However, at least one of them will be my objective to complete. And these 3 are going to be moved onto another day, right? Every day we just do 1, so that's the plan. Maybe we can do 2 some days, but 1 at least is the plan. And we can do these questions now after I do a Leetcode problem. Okay. Cool. I will do this more. I will do this, I will check the other practice problems, because there's another one, but I have to literally do it off stream. I will, at some point during the stream, cut out for maybe, say, 30 minutes max. But the stream will still be on. It'll just be no input feed coming through from my end. For at least, maybe at most 30 minutes, right? So expect that today. But the stream will still be on. I think it would still be technically recording. We'll be fine, I think. All right. Right, so first off, let me do a Leetcode problem. Okay. I'll do it here. And before that, we'll do a monkey type problem. Got the S wrong already. Dash A slash B. Hello. Oh my god. Oh my god. I'm cooked. I'm cooked. I'm actually cooked. I'm actually cooked. I'm actually cooked here. L. Haven't I seen a stack problem with 2 pops at once? Oh, I suppose this might be merging. Right, I feel like this is a problem that I might be familiar with. Operations, operators. Okay. Leetcode. Next level CPP, what is this website? I'm guessing you're talking about monkeytype. Just testing your monkey type. Nahi, am I cooked if I have to rely on VS to get the syntax right when coding? No, that's perfectly fine, you know? I mean, when you're talking about VS, I hope you're talking about VS Code. If not VS Code, I mean, VS is still alright, but I mean, I've never used it. I think if you rely on syntax highlighting, that's perfectly fine. Jamil, other days you actually start streaming sometime else. It's 12:40 midnight where I live, and it would be great if you do. So I guess here's the thing, right? I could start earlier, right? Yeah, because I'm guessing you that's when you go to bed, right? So some days I could start, say, 3 hours earlier. That would be maybe even better for you. And I've considered that because, you know, I've done that at some point as well. So 3 hours earlier being like 6:30 in the morning for me, which is something that would be good as well for me to do sometimes, you know? So yeah, expect that sometimes. Okay, yeah, Nahi. So you're worried in interviews they wouldn't allow it. So the thing is though, even in the interviews, if you don't know the syntax, there might be, you know, you might just need to become more proficient at it, but don't be too worried because you can always just ask your interviewer, hey, could I just have a look at how to write the equivalent Python syntax, right? Just be straight up with them when you're doing an interview. That say you just forget something, you can ask to look it up, right? Or you can ask the interviewer, even better, right? So if you ask the interviewer and they tell you how to write it, or they just write it for you in the same location that you're typing, then there's no problem there, right? You can literally speak to your interviewer about this stuff. But ideally, you should have some knowledge of the syntax already, right? You should have a good enough understanding how to write Python. Next level CPP, what sources you recommend for DP? For me at least, it's a very rudimentary W3 schools, dynamic programming. I guess Obsidian. Let me look for dynamic programming here. Dynamic programming. So there was one that I did, which I did also make mention. But perhaps it's in the actual boilerplate. Oops, boilerplate. So one thing I do want to say, right? Dynamic programming. Bottom-up approach, I will also say bottom-up dynamic programming. This is literally my extent of dynamic programming. So reading the Wikipedia article on memoization, I guess. Yeah, the Wikipedia article on memoization and the understanding of pure functions. I mean, that's just simple enough. By Wikipedia, memoization is an optimization technique used primarily to speed up computer programs by storing the results of expensive function calls into pure functions, right? Make sure you understand what a pure function is, and then return the cached result when the same inputs occur again. So at a theoretical level, that's all I need to know in terms of dynamic programming. And then in terms of how to create something that's dynamic programming, well, here's an example. You have an array of values. As an example, it could be maybe a dictionary for some dynamic programming problem, or it could be a 2D array for some dynamic programming problem. But I kind of see it as just a place to store your expensive compute. That's where you store it, just in a memoized or in a memo variable, DP or memo or whatever. That's the extent of my DP programming learning, you could say. Yeah, so Jamil Dang in my Microsoft interview, the guy who interviewed me was a senior and told me I don't know Java. And I asked him for some packages names and he looked it up for me in interview and was a great interview. Yeah, that's it. Yeah, that's good. Yeah, so you're very new to programming. I only know a little Python and basic HTML and CSS. Where does Leetcode fit into all of this? Like, what kind of jobs require this problem solving? Mainly for Leetcode, if you're trying to find motivation as to why we would learn Leetcode, one is for job prospects, right? If you want to go for tech roles, but the other thing is it's good to know also for back-end roles. So if you're working with HTML and CSS, that's mainly front-end stuff, right? Python is probably where mostly you would do your back-end stuff. And it depends, really. So maybe for the small apps that you build, the data structures and algorithms don't really matter all that much. But when it comes to, I guess, like apps at scale, these considerations I mean, are naturally just something you have to be aware of, right? DSA and algorithms for large projects, right? I guess that's why, you know, Amazon, all the FANG companies, because they work at scale, they do need you to know they do need you to know like basic data structures and algorithms, so you can make the best, I guess, choice for those when you're building the backend. Now, you know, that's specifically related to the backend, right? But yeah, I guess it's also just good general knowledge in general. Because when I was going for Atlassian, I went through their front end interview. Now, this was also for an intern role, so, you know, it was simpler also. But, you know, I passed the technical interview there, which was front end related, because I had applied to Atlassian through their front end branch as well. So, yeah, when I did that, you know, I was going to be a front end developer if I did get in. But but that question, they told me to build like a UI for React, using a UI for a to-do list app, and I used React, or I used Next.js actually. All right, I actually used Next.js to build that, and I passed through to the behavioral, and yeah, the behavioral is where it got me, and I didn't pass through. Right. Jamil, so did you try any books, Cracking the Coding Interview or something alike? And good job on Amazon, just saw a description. Yeah, thanks, Jamil. Yeah, so I read a little bit of Cracking the Coding Interview, but I didn't read that much of it. I kind of didn't think it was that valuable, as opposed to, say, like reading Reddit posts on CS career questions. Right. And hello, Shah. And what resources you used for Amazon internship interviews? Not gonna hold you for your studying after this. Yeah, so the thing is, the single best resource that I used, which I've said before, was this guy named Trevor Spires, who made this video called Crush the Loop.
So in this video,
right. And this guy, he explains what the loop is, right? The loop is where you have a day with 3 to 5 interviews with the Amazon team, and you know, watching this video teaches you a lot about what to expect in the behavioral aspects of these interviews, which I needed to make sure I was sharp in, because I was pretty sharp in, I guess, the technical aspects, and yeah, the technical aspects. So I was pretty confident with my technical aspects. I just need to make sure I was good with my behavioral as well. And this video was good for that. You know, apart from that, the technical aspects obviously was just doing Leetcode every day, up until the point, but not really every day. You know, I teetered off it during the semester as well. Like if you look at my Leetcode history, you would know that. But like during 8 months, like 8 months ago, I'm up until now, I've been doing Leetcode on and off, right? So. So what did you have? Wait, did you have an interview? Yeah, I did, Shah. Nahi, so what resources did you use to start learning backend stuff in Leetcode? School? Yeah, so for me it was mainly from learning in uni, right? But like additional resources that are used beyond uni were just literally the first thing I searched up for, like if I searched up you know, priority queue, in Python or whatever. I search this up, first thing that comes up, Geeks for Geeks. It could be not Geeks for Geeks, it could be W3 Schools. Usually I would probably prefer using W3 Schools because, I don't know, I just feel like it's easier to learn the stuff there, right? So Python, I'm sure there's like data structures specific, so I know there is. DSA here, right? So they have a DSA section where you can learn about all of these data structures, and like these literally are all you need to learn them well. I'm pretty convinced. And look, they're all written in Python, or you know, they probably have equivalents, but most of it is in Python. So I guess just by looking at this, most of it's Python, but you can see like you can learn from these examples basically. Did you use a specific list for Leetcode, or was it the 150 Leetcode? Yeah, it was just the 150 Leetcode, which I'm doing right now. IMO W3 is more beginner friendly. Geeks for Geeks is more intermediate. Yeah, so that's probably true then. So yeah, if I would probably agree with that as well. Just looking at some of these pages, like, yeah, I agree with what you say, Shah. Alright, now here's the thing, we'll do another backtracking problem. Palindrome partitioning was the one that one of you guys recommended me to do after I did, I think it was permutations last time. So, palindrome partitioning, we'll see how we go with this one. Alright, so palindrome partitioning. Okay. We will close some of those. I'll just, okay, I'll bring this out and I'll keep this separate. Okay. And I think we can go from here. So we need a new note called palindrome partitioning. We're gonna call this backtracking. We're gonna provide the link to this Leetcode problem. Just the Leetcode problem is enough, and we will work from here. The other thing is, I'll just open up the external link here. It's a little bit laggy, but that's alright, I think. And we'll see if we can get some sort of thinking going on, right? Let me, because I've been standing for a while, let me get my chair. Why, what do you think solving, I guess, why do you think solving just these 150 Leetcode would be enough to crack any interview? DSA part, of course. Well, here's the thing, right? If you learn them well, I don't see why you couldn't, right? You know, there's lots of people who say on Reddit they spend like 400, well, they spend time on 400 different Leetcode questions, and then that's how they got into Google or whatever. But I don't think that's necessarily the case. Like, I'm convinced that if you learn, you know, 150 Leetcode problems well, you wouldn't need to learn beyond that. And you know, maybe there's something that could be a video I make in the future where it's like, you know, I finished 150 Leetcode problems. here's what I learned. I don't know, it seems a little cringe by the way I'm saying it, but maybe it'll be useful, right? When I get to that point, you know, we're still only halfway. But that's what I'm thinking. Alright, what, instead of what, okay, what do you think solving just these Leetcode 150 would be enough to crack any interview? Yeah, I do think that. I do think it is just enough. Not just enough, but it'll probably be way more than enough. If you learn them well. Right? That's what I'm thinking. Okay, but now here, so I've seen people online say don't take notes while learning to code. Do you also recommend doing that? Say don't take notes while learning to code. Do you recommend doing that? I do feel like I waste time writing a lot of notes. Okay. I guess the reason people say that is to not get stuck in the theory as much, because in code you would have to write a lot more practical stuff, right? So hopefully that's the point that they're trying to get at. But I would say, yeah, you probably don't want to take too much notes, but the amount of note-taking, say, that I'm doing for each of these problems, I think that's fine. I think, like, personally for me, that seems fine to me doing it the way that I'm currently doing it. But I feel like you should still take notes. That's the thing, because you want to encode your knowledge. The only way you do that is through writing them into your own words in notes. Now, why do I like put quotation marks, right, in your words? Because you have to be like these words that you write them in, they are encoded by the time you write them down. Right, so you're not just like regurgitating knowledge that you found from the lecture slides or from wherever you're reading it, but you're encoding it and making some new information, or you're adding that new information that you now know into the notes, right? So you're encoding your thoughts into the notes. That's the important part. And for me at least, I also write a lot of documentation notes. So in my, say, Notion, right? So I use Notion as well, not just Obsidian. Now, Obsidian is for personal note-taking. I got Notion here for other things as well. So if we're talking, say, scheduler, this scheduler, I got a few notes here, and the reason why I do it in Notion here is because Notion is more structured, and because maybe I want to share this in the future with somebody who's working on the project as well. For me, taking the notes is like, you know, writing this or writing this, you know, so shortcuts in a sense. Writing these notes are like shortcuts, because for me, like, this is like, you know, update poetry package to a specific version. If I didn't know how to do this, I would be searching it up for maybe 15 to 20 minutes, understanding how it's done. And then by the end of it, I'll be able to encode that into a sentence and a command. And then from this command, I would know now, like, every time I need to update a poetry package, look, I can just go straight to my memory in Notion and just realize, okay, updating a poetry package, all I need to do is just poetry lock no update. Right? Or same thing with npm package updates. I would have to search this up and just make sure I understand exactly how to update something the right way, in the way that I've done it before, and you know, the only way you can do that is having notes like this. So you know, the note taking here is another, I guess, example of me taking notes on this. So I would say, like, I'd still recommend taking notes. Just don't write too much. Yeah, don't like regurgitate stuff. You want to make sure you encode it. Yeah, all good now here. Ventura notes. Exactly. So, yeah. Coming from a person whose literal name is Notes. Ventura Notes. Alright, palindrome partitioning. Whoops. I don't know how I did that. And yeah, you know, there's a distinction between you know, why I use Notion and why I use Obsidian. That distinction is still just, yeah, one is considerations of future use, like what the purpose of it might be to share these notes to other people to use, or it might just be to have more structure. Although, you know, you can still have the same structure, so you can just copy these into Obsidian just fine, right? But maybe it looks cleaner slightly in Notion as well. But I would say the main reason why I say I put scheduler notes here is because at some point I might want to share this, right? But in Obsidian, this is all just these are all my own notes that I keep almost, it literally is personally, right? Whereas these could be to the public, right? So that's like another thing that I think about whenever I choose between either of the two to write whatever. Same thing with story bank. When I made these story banks, I knew I wanted to share them, but I also knew that Notion had good database functionality, right? So this whole table is a database, whereas Obsidian has a worse database. And it's just better for writing notes. Yeah. Okay. Enough yap. So given a string S, partition S such that every substring of the partition is a palindrome, return all possible palindrome partitions of S. Shoot, man. So given a string S, partition S such that every substring of the partition is a palindrome. Return all possible palindrome partitioning of S. This might be something that I have to draw up again. I might just draw it up quickly. I'll open up here. When I feel like all backtracking problems, you're going to have to draw them up eventually. Now, I'm going to draw this, but it's going to be on my iPad. Now it is palindrome. Now I don't have that because probably I need to just refresh Obsidian. Palindrome partitioning. Here we go. Okay, and then I can probably go to this directly. Yes. Okay, now let's think about this problem more in detail. In order for myself to understand this problem, maybe I'll also look at the Leetcode here. It's just the same examples. Alright, so given a string S, split S into substrings where every substring is a palindrome. Return all possible lists of palindromic strings. You may return the solution in any order. So in this case, right, you have AAB. A, B. That's your input. Now, the considerations are possibly, let's say, if A is equal to if we have 1, if we have one length of 1, so maybe we're saying not I, but maybe L is equal to 1, or I might even call this K is equal to 1. I will call it K equal 1. Then we can split them all. And then that'll be it. If K equals 2, then what you remain with is AA or AB, but AB is not and if you already have A, then you don't do anything here. Oh, well, you don't do anything further regarding the A's. Like, all you would be left with is perhaps AB. Okay. And B, maybe you branch out to A and the second A. This one's a tough one. I don't think I can figure this one out. Yeah, I don't think I can figure this one out. We're just going to look at the solutions. and just work from there. Alright, good.
Everyone, welcome back, and let's write some more Leetcode today. So today let's look at a problem, palindrome partitioning. So we're given a string S and we want to partition it in such a way that every single substring of the partition is a palindrome. And we want to return all possible ways that we can partition it in, like, by following this rule. And if you don't remember, a palindrome is basically a string that if you reverse it, it's the exact same string. So one thing to notice is no matter what string we're given, it's possible to partition it in this way. Why is that the case? Because in this case, we have A, B. We know that any single character like A is a palindrome, right? If you reverse A, you get A. Any character, including B, is a palindrome, right? Reverse it, you get B. So one way to partition this is take each character and separate it, right? And that's what the first partition over here is, right? Each character by itself. So are there any other ways to partition this other than just this single way? Well, if you take the first two characters, you see that that is also a palindrome, right? AA, reverse it, is still AA. And of course, B by itself, we know any single character is definitely a palindrome.
Right.
So for the second partition, we'll have two substrings, right? AA and B. So then
Oh,
this is our
shoot.
result, because we cannot have any other substrings that are palindromes, right? AB is not a palindrome. If you reverse it, we get BA. That's not the same string. If you take this and you reverse it, you get BAA. That's not a palindrome. So the brute force way in this case to solve this problem happens to also be the main way to solve this problem, which is backtracking. So we are going to use backtracking to solve this problem, and what we're going to do is create every single possible way we could partition this and then check if those partitions form palindromes, and if they do, we are going to add them to our results list, right? Because ultimately we want a list that has every single way to partition this while maintaining palindromes. So for the first partition, we have three choices. Do you see what they are? If we want a first partition, well, the first partition can either be...
Give me a sec. That's very loud.
by itself, right? So A by itself, which is if we just took the first character and said that that was one partition. Another partition is double A, right? If we just took the first two characters as our first partition. Or the last one, obviously, if we just took the entire string as our first partition. Now we will check, is this a palindrome? How are we going to check? Well, we can start comparing the first and last characters, right? And we see that, well, they're not even equal, right? So this is not a palindrome, so we are not going to continue on this branch or on this path for our depth first search tree. But we know that this by itself is a palindrome, right? So this is going to be our first partition. Now we're going to take the remaining characters, A and B, and try to partition them, right? So for one partition of those remaining characters, we could get a single A if we took this first one. Another partition we could get is A, B, if we took both of these characters. But we look at the first character and last character. This is not a palindrome. This is a palindrome, but this is not a palindrome. So we don't have to continue on this path. And from here, we know we already took the first two characters as our first partition. So we only have one choice for our second partition, and that's just the character B. And we know a single character by itself does form a partition. And we also know that we have no more remaining characters, right? We already took the first three characters. So what this tells us is this is one possible way to partition to make sure that all the substrings are palindromes, right? Both of these substrings are palindromes. So this is one possible solution. So now the only path for us to continue, we can't do this and we can't do this and we can't do this anymore. We don't have any more characters. So we can continue this one. How many choices do we have? Well, we took the first two A's, right? So now we only have one choice, and that's going to be the B. So we, for our third partition in this line, is going to be B. So this one had two partitions, right? Two strings. This one has 3, and all of them happen to be palindromes, so this is also a possible
Okay,
solution.
and that's
So
it.
that's how you basically solve this problem with backtracking. It's not super efficient, right? It's going to be at least 2 to the power of n because we're brute forcing it. But now let me show you the code. So let's have our result. This is what's...
Hold up, right? Because it seems like he goes back to... I think he made a mistake, right? I think that's a mistake. Where he starts the coding explanation here. Doesn't matter. Doesn't matter. Doesn't matter. Doesn't matter. Doesn't matter. Okay, but I can kind of you know, redo this in my own way. So A, B, can be partitioned into A, B. B is not 1. Now A can go to A again, or it can go to AB. Now AB is not 1, that can be done. A can go to B and nothing else, and which means that's one valid solution. And A goes one more to B, and then that's our second valid solution. Okay, cool. Okay, now we can solve this problem. So this is, you can consider this to be like after watching video solution. Guy you can trust, so you're on backtracking bender, right? Yes. Have you done n queens yet? Classic backtracking problem and fun to optimize. I have not yet, I didn't think. I wonder if it's going to be in these Leetcode problems. Yeah, it is going to be. So if that's going to be the hard one, I think that'll be like the end game for backtracking. So we'll get there. We'll get there when we get there. We will say though, so Leetcode solution, Leetcode method. Alright, so this is the Leetcode method. No, it's not necessarily Leetcode, but it's not necessarily Leetcode who created this, but it's there anyway. My method, Leetcode method is what I should say. My original attempt. All right. Alright, and it doesn't matter how we do this in breadth first search, depth first search, I don't think. Alright, we'll just do it. So go back to the questions. So, you're given a string. You want to split the string so that you have substrings. These substrings substring. You know, I could just call this string. I'll just go with string for now. Alright, let's see. Maybe I'll just call this S as well. Now, you're going to backtrack such that you go through the different substrings of the length of the string. Should I call it I or should I call it while I does not equal len of string I equals 0, I plus equals 1. That's where we do the backtrack. I know I can do this in ranges, but it doesn't matter. S is going to be I to the end, so it's going to be, oh nope, it's going to be up to I plus 1, I believe, because it's going to be starting from 0, meaning it's going to be at, so 0, 1, 2, cool. So instead of a while loop, I kind of want to now just change this to a for loop. For I in range of len of s, backtrack. And this is where we can do the check of is palindrome. If it is a palindrome, then you would okay, if it is not palindrome, then you wouldn't continue. But if it is palindrome, then you would go down further. If S is equal to an empty if S is equal to, so if len of S is equal to 0, then you would return what would you return here? The string. It's going to be an empty string. So if len of S is equal to 1 maybe, len of S means you're just going to return S. but you might want to return the base case list. And when you backtrack, you might want to return plus equals. Some call it path. Oh man, this is actually, if not palindrome, you'd return nothing. But if it is a palindrome, you can build out a path, add it to the result. Maybe put the path outside, add to path, and then path dot remove or pop. So I can't really add it here, but you can path.append here, path.pop here. That means the path doesn't get changed there. If it is equal to 0, then you can append every time you are here. And you're going to now check if it's not a palindrome. So if not, if, I don't know, while I is less than, while true, or while I is less than len of s divided by 2, perhaps. If s of I is equal, does not equal to s of I len of s minus I. If that's not the case, then you would return and then you just keep on returning. Interesting. I'm not convinced this will fix anything, this will be the solution, but we'll see. Not accessed. Okay, I is equal to 0. I guess I plus equals 1. We could do a while loop, right? But I guess we could also make this into a range as well. So for I in range of this, just removes that. Float object cannot be interpreted as an integer. Yep, so that's not entirely the correct way. Could I do a mod? Sorry, a floor. String index out of range for sure, so +1. This index is still out of range. So here's my considerations. I gotta be more careful here. Okay. Now, if the length is even, when you floor divide it by 2, it'll be 1 plus 1. That would equal to 2. Now, I guess you can make this a 2 pointers, right? Make it a 2 pointers problem as opposed to this. It might just be easier for you. So left is equal to 0. Left right is equal to 0 and len of s minus 1. While left is less than right, 0, if S of L is equal to S of R, so if it's not equal, return. And then otherwise you would just L plus equal 1 and R minus equal 1. Until left and rights equal. Or overlap. So if left and rights equal, it will mean that that last value is going to be the same regardless. And if you don't make it equal, then it doesn't matter. Okay, so my output, obviously, because we don't ever do anything to append the path. Res.append path. Res.append path.copy. Okay, so we never... Okay, we reach an error. So if your string is just one character, then you would be fine. Check if palindrome, I guess. Check if palindrome. Now, if that A is equal to 0, which it isn't, 0, one. So if I is 0, then it should just be 1. It should just mean S is returned. Does it ever become 0? So if S is 0 now, no, you just return. But path.append the string. And then once you're done with the backtrack, you pop the last value of I'm missing the point here. There's something that I'm missing. I'm missing the point. There's something I'm missing. So, okay, let me run through the example of AAB here, right? So, given a backtrack of AAB, stdout only returns AAB. Why is that? Where does it return? Hello world. It's not going to return there, is it? It does. Oh. I shouldn't be doing this check here. Because if it's not a palindrome, so AAB is not a palindrome, right? If AAB is not a palindrome, then it would just return straight away. So what's that guy you can trust? So size is 1 is less than, so mine is less than 20. It's not so bad just to enumerate every substring and return early for failed checks. Yeah, exactly. So I mean, that's how I am trying to do it. That's how I'm trying to do it. Now it's just at this palindrome part, okay. Stops before we can actually reach anything but y. So you backtrack. If the string is equal to 0, then you would append the current path that you currently have, and then you would return. But if it's not equal to 0, then you have to check if it's a palindrome. If you check that it's a palindrome, and it is a palindrome, then you would append. But if it is not a palindrome, you would return. And not do appending. So my feeling is this has to go before that, where you backtrack through all the different ways that you can make substrings. You would keep on backtracking Yo, okay. There's a lot of messages. Let me read this. So, David, another 10 hours today. Maybe. So, guy you can trust at every level. You can see, you can check if I is less than n, and partition the string of size 1, 2, 3, etc. Yeah. Yeah. Separate function that returns a Boolean. I guess you can have a separate function that returns a Boolean. Makes it easier to understand, I suppose. And is that right now? Let me think. Nah, I'm not convinced, but we'll just run it anyway. ABA forever. Now there's an infinite loop on A. I think I know why. If it is a palindrome, you want to do this check for the underneath. Man. Is palindrome? It's not. But why am I doing it for something that isn't a palindrome to begin with? Should I instead be doing it from, not a palindrome to begin with? I mean, I should start from a palindrome. Hold on. Am I using these S's correctly? Let me just make a few distinctions. Alright, we'll just call it substring, right? Substring. If substring is equal to 0, you append the path. If the substring is a palindrome, you append substring. 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 It's all correct. There's no need for the S's. And then I think I'm at a point where I'm stuck, so there's something that I'm missing fundamentally. So let's just look at the solution here. Is palindrome. So this function though is fine, right? You pass DFS I. Start from 0. If I is greater than len s, res.append the part copy, return. And here's the thing, I do this. Right, I mean, wait, this still doesn't give it. Hmm. What's different? All right, no, something's different.
There we go.
I think I found my mistake. Maybe. Never mind. I will keep on trying. Ugh. It's a... Okay, so it's the small bugs again, right? Okay, but let me read what you've written here. So your function looks like this, list of lists called ends backtrack, string s, int I, list of strings v, int I, list of strings v, if I is equal to the size, you can append the v, return j equals I. Okay, I'm somewhat following. While I is less than n, a temporary string is equal to the substring. Start at I, length. Okay, I'm lost. Is palindrome, backtrack, pop, temp, I++. As pseudocode. Dang, it's not formatted right. Invert the logic, reverse when your substring is a palindrome. Recurse when your substring is a palindrome. Expand the substring length. Sorry, return from the call when I equals n. Okay. One thing I do also notice is if I... So let me just submit this to make sure it does work. Okay. I'm going to undo a lot of this. If I had it like this. Okay, redo. And I were to have it like this, but I backtracked it correctly. Would this also work? Not always. Yeah, okay, I had to do it the way that I had before here. Copy. Okay. This one's a pretty difficult question, regardless. Guy you can trust. Thanks for sticking along. That was actually pretty tough. Okay, so the thing is I gotta write some notes here now. I got stuck on a little bug when string slicing Python. Right, so that was my biggest problem. I also had issues with the order of for and if for the backtrack function. You need to build out an is palindrome and a backtrack function. Functions. Now this backtrack function is done in a DFS manner. DFS manner. Because it is easier. Lastly, we just need to add DFS. And palindrome. So palindrome stuff, this is related to palindrome. Palindrome. I feel like I did palindrome one time, but maybe I didn't have a note for it. Okay. Also, man, this is W. The logic looks a little weird to me. I was recursing inside the loop as it grows, so does the substring. I maintain a separate list of pushing popping candidates until I is equal to n. Yep. I mean, yeah, so you were recursing inside the for loop. And that's what I do as well. That's what I did as well. And maintain a separate list for pushing, popping candidates. Yeah, which is what I did as well with my path variable. But yeah, that is the general idea, you know. Pushing and popping. Man. This is tough, but we got it, okay. We'll call it that. Just put it here. And then we'll also go to alacrity. (131) palindrome partitioning. Yeah. Now I should also mention Leetcode uses indices a lot more than me for this problem. Leetcode and git push. I forgot to push. Okay. Done regardless. Not bad, but this is a good problem. It was a good problem. And we're going to call it for that, for now. Let's see, so how's the progress going overall? What are we planning to do possibly tomorrow? So letter combinations of phone number and then n queens as the hard problem. I could try doing n queens as the problem tomorrow, or I might try it the day after I do this. Maybe. Alright, we'll try this one because yeah, backtracking problems are actually pretty tough, to be honest. But we're slowly getting through them. I feel like tries and graph problems are easier than some of these backtracking ones as well. Personal feeling, at least that one that I just did was pretty tough. Alright, I'll do one of these. Okay. Cool. So now, done with that. Close that. Let's now look at doing some of these APA problems. Okay. Instead of computer vision, we go to APA. Okay, here's the thing. I need to pause the stream. The stream's not going to have any feed for a bit of time while I try to extract the questions from a different practice exam. Right, and you can only do this through the Respondus lockdown browser. So I'll be back in around 30 minutes. The stream will pause momentarily. But let me just make sure that is how it works, I think. Where is it? Details, I think, maybe? No, I think it's specifically in the live control. So auto stop is turned off. Alright, we turned off auto stop, which is right. Okay. Alright, we will close. Yep, I'll be back. That's good. This is basically all the same as these, except the only thing that I did get new here was this screenshot. This is what grid with hash was. So I can delete those images and we're fine. That means when I go to these problems, it was what I expected, so this is now considered complete. You can do the tutorial slides, go to do some of these problems, gotta drink some water, I'll be back and I'll get started on at least 2 or 3 questions from here. Alright, right back. Here's the thing. I'll be back in an hour to... I got to make meal prep today and eat lunch. Ideally, look, I'll be back in roughly an hour and a half because I got to eat it, but also have a shower. So that's the plan. And I think by the time I'm back, I should be pretty fresh to continue anyway. Because, what are we saying? The dip happens at 12:20. And we're saying that the peak would happen again at 4. So, yeah, I'm gonna make my food. Alright. BRB. welcome back. Lunch. I'm gonna say no gym today because I already went for a walk, but also because, yeah, I spent a lot of time doing meal prep, so I don't think it's worth doing it today for this. Right, now the thing is I should do at least one question before doing a scheduler development. I can say I've done all of these now. Okay, cool. Let us do a practice question right now. Shouldn't be bad. Hey yo. Someone got an offer. I wonder for what. Come back, but NZ and come back. I see. Is this also? It's pretty fire. It's so funny. Career channels again. Yeah, okay. Interesting. Alright. Let me move this. Oh no. Because I can't move it back now. Look at the LinkedIn. Hello to the new person that arrived. Got a message from MHH. Might have to respond. Might have to make a response. Okay, so I can delete this. But this note gets deleted and this gets deleted. Okay. Cool.
Kia.
Trunk and Monkey. If you sent that, I hope didn't miss that. Hope you're still here actually. But do you go to your classes usually? Some classes clash and I have to just not go to them, but most of them I try to. This semester, at least. George Vell. So how do you self-host your notes? I have a repo for my notes and I just push updates, but how do I get it synced so I can use my iPad too? Yeah, so that part is harder than, it's not easy, is what I can say. But you need kind of, for me at least, you set up a server for the self-hosted live sync. You get the extension from Obsidian, the self-hosted live sync extension. This one, and then you kind of have to do a sync, which takes an hour or so. And then at least for me, it took an hour or so because I had like 3 gigabytes of data. And then you have to do the same thing and sync it for another hour onto your iPad. And then once you have that, that's how you can make it. But I did it through a lot of trial and error, you know, because, you know, maybe sometimes I would delete the whole repo from my iPad and then add it on through a sync again. But I don't know if it's worth doing all that. You know, if all of that hassle, I wouldn't recommend it to anyone. For the sake of syncing, like I would just almost go with Obsidian's own sync. So every time you make a change, it takes an hour? No. Well, you know, it's instant after that 1 hour of initial setup. And after this initial setup, you're good. But every now and then they might have updates, and then when the updates come, you also have to continuously, okay, some updates make changes to the actual database on your home server, and then when that happens, you kind of have to resync it all, and then it takes another hour for each of these devices to sync up. Which is, you know, what's bad about using this, right? Because it's by some guy who's, I think, he's Japanese, but he's maintaining this repo, and it's not, like, even looking at the settings get confusing quite quickly. Like some of this stuff, if you go into the maintenance section, like all of these red buttons, like there's just way too much going on. Anyway. Let's see. Hello, Cyborg Gaming. Recall that A star requires a consistent heuristic to guarantee finding an optimal plan without reopening nodes. Okay, reopening nodes is an interesting way to describe this. Draw or define a graph and make up an admissible but inconsistent heuristic function where A star returns a suboptimal solution. An admissible but inconsistent heuristic where A returns a suboptimal solution. Write down the steps involved in the A star algorithm by devising a simple example to illustrate. Note: avoid making large examples. A graph with 4 nodes should be sufficient. Okay, let's see. I just saw your guys' messages. What's your opinion on penguins? They're pretty cute, not gonna lie. Real question, have you made mistakes in your past life that you regret if you acted more confidently instead of overthinking? There would be situations like that, but is there anyone that I'm willing to share? I guess for me at least, I don't necessarily overthink. Not that much, I don't think. There's definitely a situation where I have, but I can't think of one at the moment. I'll get back to you, Prayash. I'll think about it during the night. Will we get pre-placement for Amazon or just internship? At the moment, I think what happens is if you're doing the internship, if you do well, that's where you get the return offer. So if you do well, which I think I'll do just fine, I should be able to bank a return offer. I think it'd be alright for me to do that. I'm pretty confident in that respect, you know what I mean? Yeah, I mean if I get to there, you know, still. And be good enough. And then for sure I'll give you a referral. I'll remember you, enthusiast. Define the heuristic values h for each node. H is 3, 1, 2, 0. But we need to say, so requires a consistent heuristic to guarantee finding an optimal without reopening nodes. Draw or define a graph and make up an admissible but inconsistent heuristic function where A returns a suboptimal solution. Can I say, like, give a... what h of a would be, if h of a is 3, h of b is 1, h of c is 2, and h of d is 0, goal node. If I take, say, the Manhattan distance, that wouldn't, that would be that would be admissible. Yeah, inconsistent and consistent stuff is kind of hard. This heuristic is admissible because it never overestimates the cost to reach the goal D. But it does in A, doesn't it? However, it is inconsistent because it doesn't satisfy the triangle inequality, where the heuristic difference between two connected nodes should not exceed the actual edge cost. So A minus B is equal to 2 when it should equal to 1. Right, for example, the cost of A to B, yeah, violates the consistency, so I can kind of get that. Alright, yeah, do that enthusiast, let's go. Steps in A star. So an open list with a start node A, FA, GA, HA. So you're right, FA is equal to GA and HA, right? Which GA is 0, like the GA is the actual cost, plus HA, which is the heuristic, which equals to 3. So expand A. You would move to B or to C. Right, G of A is equal to 1 and 2. G of B is equal to, so F of B is equal to the heuristic at B and the heuristic at C. So you'd have f of c to 4, f of b to 2, then you would choose b because it's the lowest f value, and then you would expand g of d, which is equal to g of b plus 1, which equals to 2, and then f of d is equal to g of d plus h of d. H of d is 0, so yeah, 2 is the next goal. Goal reached at D with cost of 2. That's correct, I agree. So although A reaches the goal D, or A star reaches the goal D with the cost of 2, using this inconsistent heuristic could lead to reopening nodes in more complex graphs. So admissible but inconsistent.
我感觉到另外一张也是同样的有意 Office Works 对。
Admissible but inconsistent. Search algorithms.
你看我是在 Smiling 吗？
A star will reopen nodes if it encounters an inconsistent heuristic. Non-monotonic heuristic. An inconsistent heuristic fails to satisfy the triangle inequality, which means that for node n, the successor n prime, the following condition does not hold. H of n, say some length, C of n to n plus H of n n to n
And how the email cannot be printed.
n to n prime cost plus the heuristic of heuristic of n prime. From n to n prime, the heuristic of n prime, the heuristic of n is less than or equal to the cost between n to n prime plus the heuristic of n prime. Looking at this solution, consistent yeah, well, that is exactly what I just expressed. But it's inconsistent. Does not pass the triangle inequality. And the triangle inequality from SA to S prime, that means S prime has to be, in order to be consistent, S prime has to be less than H of S minus the cost of A. H of S prime has to be greater than H of S minus the cost from S to S prime. That doesn't even fully make sense to me. I know examples will help, but this is a tricky one. I never understood if that was an accident or not. S is an element of S. I think S should be just an element of big S. I might just say big S. Yeah, fuck it doesn't matter. Okay, but When this inequality is violated, it can cause A star to underestimate the true cost of reaching some nodes, potentially leading to a suboptimal path. If a lower cost path to a node is found later in the search, A star will have to reopen that node and update its path cost. Mohit, when is my exam? This is coming in a week. Basically a week from now. So consider a path from the start node S to the goal node G with an intermediate node A. Suppose HS is underestimated compared to the true cost. Causing A star to expand a less optimal path. It's so confusing with underestimates and the values of these heuristics. So once A star explores node A and finds a more optimal path to G, it must go back and update the costs for already expanded nodes in order to reach the true optimal path. Conditions for reopening. Reopening occurs under two conditions. On an inconsistent heuristic, if a heuristic is inconsistent, A star may initially underestimate the cost of some paths, and then later find shorter paths to previously closed nodes, forcing a reopening. Suboptimal paths. If an algorithm explores a suboptimal path due to heuristic underestimation, it might later discover a lower cost path and reopen nodes to adjust for the correct minimal cost. Using a consistent heuristic where the triangle inequality holds guarantees that A star will not need to reopen any nodes. Inconsistent heuristics may result in reopening but are still admissible. Meaning A star will still find an optimal path, but less efficiently. Interesting. I guess that's the main takeaway here. An inconsistent heuristic leads to reopening. Write down steps involved in the A-star algorithm. By devising a simple example to illustrate. I guess, is Manhattan distance an inconsistent heuristic? Will Manhattan distance be an inconsistent heuristic? It could be. Right? How can I think about this? Okay, fine, I guess it's some of this.
几点钟？我都有点想课了，刚摆明，看那个人。
Let's do some scheduler development now. Hello, Dankoa. clean install on Asus G15 gaming laptop with Pop! OS. Kinda excited to do a dev projects on it. Windows 11 really bloated it. Fair enough. John, what are you talking about? And Void, I want to ask, what were the Leetcode and aptitude questions asked in your OA? I don't remember the exact questions they asked in terms of my behavioral aspect, but the Leetcode questions was a graph problem, and which was basically to build the graph and then search through the graph using BFS or DFS. And then it was also a array problem called longest substring without repeating characters, and that was the Leetcode problem. The longest substring without repeating characters. What? John Tidor. Whatever, man. You're down bad for no reason, man. Yeah, they did ask me a Leetcode question directly. Yes, 2.0 approach is the way, so that was immediately to me as well. I was like, yeah, we can use a 2.0 approach. Basically the whole interview I was just talking through and writing out the solution. And we're talking like 50 minutes of me doing that, just speaking and speaking and speaking. But that, you know, that was fine. He liked it in the end. But in terms of like, say, the behavioral, right? Behavioral questions, make sure you have like some failure stories. In the sense that, you know, you didn't meet a deadline for some reason. Why didn't you meet it? What was the, you know, use the whole star framework around that situation, that story. I created 2 last minute and both of them were used. Like 2 of those failure stories last minute and both of them were used. So, yeah. There is an OA before the interview, right? Yes, there is. But the OA for me was 1.5 hours, and then another 1.5 hours of behavioral essays, like where they do these like multi-choice answers, where you put it, your like multi-choice is the scale, and then you just have to say the question is like, given the question or the statement is, I am an organized person, and then there's a scale of yes I agree or yes I disagree. Like those types of behavioral assessments are also there. So I did that as well. It was a little bit, it was 3 hours in total. So feed navbar or feed add navbar? Feed add navbar. Always make it a verb and a present tense verb. Oh, they asked behavioral too, yeah. So, if anything, the behavioral at Amazon is more important than your technical in terms of the interns. So just watch out. That's all I can say. Ooh. Don't know why I fell asleep while sitting on a chair. Any hack to not feel sleepy? My hack would be to sleep for 20, for nap. I would actually say nap for 20 and then come back to your seat. If you're actually feeling tired. That's what I did yesterday. You'd be surprised how beneficial that is. Any interview experiences with other companies? I did with Atlassian, right? So Atlassian was the other one. TikTok was another one. I did one with a small tech firm, and that was, yeah, just like local, Melbourne. But that was the extent of it, I think. That was mainly it. Void, so also as far as what I've heard, the Leetcode on OA is pretty straightforward, like direct questions like you mentioned. Is that always the case? Yeah, so the Leetcode, I think, so definitely for the Atlassian OA, they just use Leetcode questions from my experience. But for Amazon and TikTok, they both had their own questions as well, specific to Amazon or TikTok, right? So at TikTok, blah, 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 blah. At Amazon, they have this, I don't know, blah, 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 right? So they do make their own specific questions. At least for TikTok and Amazon. And probably Microsoft and Google. Or Google obviously will. But yeah. But they are still pretty straightforward. At least for my Amazon one, you know, I passed the first question, and I completed the first question, and the second question I only got maybe a third of the test cases. Same with TikTok, but for the Atlassian one, I literally was able to solve them both. No problem. What do you think is important in the Amazon OA? Generally, okay, so for me, what I found to be the most frequently, from my experience, what was the most frequently used data structure was heaps or heap queues or priority queues, right? So priority queues literally came up for 3 different OAs. So I had a heap queue problem for Amazon, for TikTok, and I think Atlassian. So all 3 of them had a heap problem. Atlassian had a dynamic programming problem as well. TikTok had, I'm not sure if it was an array problem or not. But yeah, arrays. Dynamic programming was definitely one for the Google as well when I did that OA, but honestly I didn't even know what I was doing for that one back then. But Amazon one, definitely heaps, was the most frequent out of all the OAs. Yeah, Google always asked DPs and graphs, exactly. I'm pretty sure when I probably did a Microsoft OA as well at one point, and I remember graphs being a problem always, and back then I didn't know how to do graphs. So, yeah. Gotta keep up with the Leetcode stuff to keep the rejections away. Yeah, a Leetcode a day keeps the rejections away. You'll try to apply for Amazon next year? Yeah, alright, perfect. Try and apply, you know. I gave you some information. Hopefully you should be set. If you just practice and shit, I guess. At least you're more aware now. Oof. Good. So those are the 10 files? Why is it 10 files? We'll just add them all. Yep, 9 files at the end of the day, good. Also, I sometimes don't know when to move on from a topic. How much would I practice one topic, Leetcode wise? Literally, for me, it's just following the Leetcode 150, right? Literally just do those questions, and during those questions, that's when you do the review of the DSA, the specific DSA, and you should be fine. That's my thinking. You won't know it to 100%, right? And you shouldn't try to know it to 100%, right? There's diminishing returns. So just know it up until 80%. The last 20%, like, I guess it's like corner cases and whatnot, right? Maybe, you know, for me at least, the 80% that I know of DP right now, I know there's like there's a bit of corner cases with respect to the different ways you could perform DP, right? Those different ways to perform DP, I still am not fully familiar with. Also, by no means am I actually done with learning DP yet, but this is just an example. But if I don't know, like I know I don't know all the DP ways to do things. Like you could use an array. I know you can use an array to store the DP solutions, but you could probably use a bottom-up DP, right? And the bottom-up DP I haven't had enough practice on, but maybe I'm fine with that. Maybe I'm okay with not knowing that. I guess you can say pick your poisons, but maybe that's also not a good example because maybe you do want to know your bottom-up DPs better. But there's some other like edge cases you could say that are better examples than my DP example. Hopefully that makes sense though. I don't know, like maybe like DFS. Learning the DFS through brute force, not brute force, through recursive versus through iterative. Maybe, you know, you know the brute force, know the iterative, but you don't know the recursive. That also is not a good example because you kind of need to know them both anyway. Just because they're kind of like half and half in terms of they're not really like 80%, 20%. I mean, maybe the Leetcode questions you come across can 80% be done by a recursive DFS and a 20% done by iterative DFS if you wanted to for fun. You can think about it that way. In which case then my argument holds that you don't need to know iterative DFS if you're short on time, maybe, right? Anyway, maybe that's still not a good enough example, but Just don't go 100%. Just don't aim for 100%. I think that's really the key. And I learned this the hard way, by the way. Just for learning in general, like going for 100% really takes a toll on you. It's better to just go for the 80. Leetcode Lab. So what am I building? I am building my scheduler personal project. Now, it's an open source app, right? So that's why you can see everything that I'm building. But the main idea is so that people can have better, I guess, visualizations of their week. That's the idea. Simply put, I guess. But yeah, automatically schedule tasks and see it in a calendar view. You know, you can go to the staging if you really wanted to have a look, but it's not very functional at the moment. Demo@example.com. Demo as the password. You know, these events don't really move anywhere at the moment. You can change these dates, you can shift them around, but it's a front end thing only. You can tick these, but they get reset as soon as you refresh. And these buttons are actually bugged right now. So I know how to fix these as well, it's just I haven't gotten around to it. But yeah, like I'm basically focusing on the front end at the moment for this project. Now, there is a backend aspect which is the crucial part, which is the scheduling part, which I need to get to at some point. But I thought learning front end here was more crucial, mainly for my own learning, you know, because yeah. Anyway, I think I can log out of that, but yeah, this is a front end page. This is also a page that I built copying from ShadCN as well. I think it's pretty good, looks wise as well, like it's pretty simple, neat. Anyway. Yeah, I was trying to completely learn binary search, but realized there were way too many problems. I think it's better to just learn the most important ones conceptually, yeah. The stuff that comes up 80% of the time, those are the ones that you should learn. But anyway, yeah, this project is open source. Anyone can view it. Anyone can look at it, look at the issues, or even write their own issues. Yeah, anyone can contribute. Regardless, I think I am done. I'm happy with just like finishing two of these notifications. I do want to get rid of some of these other notifications that just aren't necessary for me to know. Restic, TANstack router, usage of storybook. Yeah, I mean, I'll come back to this as well, learning this. Vault Warden, latest updates, and we've got image latest updates. Now, does image have any bad things? Ooh, there is some stuff that needs to change, perhaps. All good, Void. All good. Are you a web dev, by the way? Well, you could say that. You could say I am, but I'm also still just a student. I'm just trying to learn, you know, this project that I'm building is also me trying to learn about web development as well. So I wouldn't necessarily call myself the best web dev or like an actual professional yet, but definitely knowing about this stuff now is better than never, right? So also opens my doors to collaboration. But yeah, there's always more to learn. You're right, you know. But I still wouldn't consider myself a professional yet. At all. Like, at all. Okay, so the M variables for the host binding were erroneously named host instead of image host. Which is how it was listed in the docs. This has been corrected. If you were using the host invariable in your setup before, please use image host if you're using the built-in Prometheus endpoint. Following invariables have been removed. So example of image metrics true. Alright, I don't think that applies to me. I think I'm fine. That means I can just update straight away. Okay, patches, yeah, for sure, okay. So we're happy with that. I will say then we can shut down. And we can go back to ticking off scheduler development for now. Peace to that. And then yeah, I want to do one lecture slide. Not one lecture slide, one what's it called? Tutorial slide. Guess is the best way to say it. Just quickly checking my emails. I don't think there is anything for me to consider there, so I'll close it. And okay. Now more important stuff on the horizon. I can only do so much of this because I kind of want to have the solutions right next to me and stop me from overthinking some of these questions. Definitely, like, I do overthink them sometimes. So it will be good if I understand, you know, what this means. Maybe just don't have to answer it. Understand, but don't have to answer. That might be the plan. Even for this section. PDDL. If I do that though, yeah, one step at a time, why not, right? Just one step at a time. Yeah, let's just have a look, maybe for 10 minutes. So might as well spend 10 minutes here. There's something about Siri that I can do now, but I forgot how, or I don't know how. No. Hello. Hey Siri. Hey Siri. Nope. Doesn't work. I can press it. No, it's just not showing up now. Oh. What's my name? Okay. There was something I could do. Doesn't matter. Okay, the next 5 questions refer to the following example. They concern a classical planning problem where a robot can move horizontally, vertically to adjacent cells as depicted in the figure below. Note that the robot cannot move diagonally between cells and the hashed cell is inaccessible to the robot. In answering the sub-questions below, you are allowed to use variables as arguments for the actions. Yeah, my whole point anyway was to time 10 minutes. Consider that the position of the robots could be modeled as either row column tuples Give me a sec, gonna drink some water. Jamil. Court just slept 3 hours, but have some energy, bruh. 3 hours only? Damn. It's actually crazy. So describe briefly in strips how to model the problem where a robot can move horizontally and vertically among adjacent cells, such that the h-add heuristic estimates the same values as the Manhattan heuristic. So h-add I've got to relearn, right? So let me underline this term, re-understand, but from what I remember, we have a h-add, we have h+, we have h. There's more, I think, but h-add and h+. Let's just think about it that way. Strips is a different thing that I got to remember as well, because there's strips, and then there's also PDDL, I think, or whatever language or whatever tool PDDL is trying to model, because PDDL is the language, strips is the model, but there is another model for, I think it's FOIG, FOIG, which can be modeled as strips, but strips might not always be modeled. Wait, FOIG might not always be modeled as a strips. Strips is basically a subset of FOIG. Okay, I remember that. I remember all of those terms. Anyway, strips, add heuristic. This is where we gotta relearn exactly what these terms are. As the optimal heuristic, Okay, Manhattan I understand, but optimal heuristic. Okay, and then use the last strips encoding where h-add is equal to h-star. An initial state S0 is equal to robot at location I, and a goal state SG is equal to robot at location K. Okay, H star, right. So H star, circle that. Something I gotta re-understand for a bit at some point. Man, I'll just arrow it. Don't need to circle it. Man, let me arrow it. H star. Okay. What's up, Akshit? Good review of ERDP. What's UMCPC doing here? Cat eating spaghetti. Russian version. Got a whole lot of yap going on. Alright. Regardless. That started off really good. Hello KFC once again. I'm good. Hopefully you're doing just fine. It's actually pretty annoying. But I guess, you know, this is all the whole process of learning. Use your last strips encoding where h_add is equal to h star, an initial state and a goal state. So I and k, yeah. Compute h_add sg and hff for the best supporters induced by h_add. Right, so hff from the best supporters. We have two rooms A and B, two objects O1 and O2. Okay, I think I kind of like looking at this one. A robot can load and unload objects if the robot is at the same location and move from one room to the other. Can move from one room to the other. We want to get O1 and O2 into room B, given that both are initially at room A. Model the problem in strips in such a way that the optimal plan would be the following. You pick A, move A to B, drop B. Oh, drop to B, I see. Move to B to A, pick object 2 at A, and then move A to B, drop O to B. Yep, so I can think of how to model this. States, transitions, rewards maybe. Initial state per something. I don't know what S is again. Okay. And what is the H max S0 value of your strips model, where S0 stands for initial state? H max is another one. Okay, this one's tough. And then game theory. Alright, what we will do is I'm gonna remember those slides. These are probably going to be the single most useful slides to understand those algorithms. Let me understand, let's see. Where is H of FF? Might be in the slides after this. Good introduction to AI planning. It's just normal. This is just normal, I think. Yeah, this is normal. But intro to planning. So this is where we bring up the strips idea. Generating heuristic functions, right? Using FOIL, right? Has to be. But these block problems, width-based planning, extensive form games. Okay, I mean, looking at the whole subject, I can kind of reminisce on the subject pretty well. It will require me reviewing the content. Okay, but the next thing to review is this. So I can put this as next step. What section is this called? Whoops. These are tough. Game theory though might be the easiest one. So should I review that first? I think it's worth doing the game theory once, maybe even today. Alright. And then tutorial slides review, like that requires, that's partially something I gotta do, but I think reviewing game theory before finally reviewing reinforcement learning is fine. What's your monitor display refresh rate? This one right now, since it's a 1440p, it's 60 frames per second. But if I have like a 120, I got a lower, a 1080p resolution one right next to me, which I could use to run 120 hertz on. And that's just a limitation of my current connection, I think, my current adapter. But yeah. Can I learn backend without knowing frontend? Of course, yeah. If anything, that's the first thing you learn. Because you think about it, right? Like, even learning about, like, say, Python scripts when you're just writing Python scripts, that's technically a little bit of backend, you know? That's technically backend. So, technically. Understand all questions from game theory. So I can understand all questions from game theory now if I want to, right? Spend the time on that now. Might as well. Also, wait, didn't I put a timer? No, I didn't. I never put on a timer. Should I do it? Shouldn't have to think about it. Shouldn't have to think about it. Shouldn't have to think about it. Alright, let's read up on game theory. Maybe try and do these questions because they might be okay to do. Especially this one here. Because I've seen someone already complete it. Namely Adam Mantello. A very Chad fellow. It's a potential. Good hint. Okay, let's try and write this one. Jesus. Oh no. It's gonna get real loud for a second. So we're gonna be muted for a little bit. Dad's gonna put on the vacuum. See this? You hear this? Okay, vacuum's off now. But this tells us that M is just not in consideration. If M is not in consideration, well then the problem becomes trivial. Y, 1 minus y. X, 1 minus x. find all pure and mixed strategy equilibria. So pure is going to be interesting. So we need to find this reference of pure and mixed strategy. Find their differences. Okay. I guess this exam revision I could just go like I could do that and just be like that. Could be dodgy like that. Maybe have something like this. Check marks. Pure and mixed strategies. Now this is for game theory. Okay. What are all the different heuristics? You know, there's like HAD. I guess first is H star. HAD. H plus. I think I might make this that. Oh, trick or treat. We don't have anything for trick or treat. That's a problem. I was just looking out into the window. Sorry you saw my literal backside for a whole minute. I totally forgot today was Halloween. Can I be fucked? Not really. My social anxiety could never. That's a very good explanation. Akshay, I'm from Australia. Mm-hmm. Mm-hmm. Guess we'll just call this normal form games, yeah? Be normal about it. Something sus. Here we go. Taking forever to load. Yo, why is this taking 100% of CPU, you know what I mean? Is it really that intensive? Okay, extensive form games don't matter here. But normal form games do. So do you want to work out Fang? Yes. But only for a time in my life. So not always. But for now, at least to make the money, yes. And I think I have a real chance now, you know? Given that I'll have an internship. And after the internship, ideally, you know, if I don't get a return offer, I can go through the grad process and I'll still be good given my sharp Leetcode skills. Or sharp enough. Jamil, so am I doing any bachelor's? Oh, am I doing a master's or bachelor's right now? I'm doing my master's, and my bachelor's was basically, yeah, computer science. Or at Melbourne Uni, we called it computing and software systems. And so that's what I did in my bachelor's, and yeah, like literally the year after I've started my master's. So that's what I'm doing right now, you know. Hey, nice Jamil. Almost there, man. I'm technically pretty close to next year. Is when I'll graduate. It's gonna be interesting what I get up to. Okay. So a normal form game is a tuple. Akshat, so can you suggest a roadmap for Leetcode, like how one should start it? Leetcode always feels never ending. That's it. So I've always recommended Leetcode 150. Leetcode 150, alright? So check that one out. That's the best thing you can do with structured Leetcode practice. And in terms of, you know, when I first started doing Leetcode, well, that was probably around 8 months ago. Actually starting properly doing Leetcode. I did go on and off with it, right? So, look, Leetcode 150. I've done 84 questions now, give or take. And yeah, we're progressing all right. This is my timeline on Leetcode. You can kind of check it out once it's open. See, yeah, like look, I did a bit here when I was first doing for Atlassian, and then I did more for some other OA that I had at some point, which then I dropped, and then I did some streaming. So when I did more streaming, I did more Leetcode, and same thing, this is like a checkered pattern of my Leetcode practice almost every second day. Funny thing is though, it happens to be every second day, which is very interesting. Like, is this 31st? Yeah, it is. I didn't do it yesterday. I did it the day before yesterday. Didn't do it the day before that. I did for that. Okay, but anyway, that's kind of like the progress so far. Like 2023, once in November. 8 submissions. Yeah, you get the idea. Also, personally recommend Structy to supplement your study if you're struggling to recognize the patterns. Fair enough, yeah. Fair enough. So Akshit, if you want to take that on. So also, do you think Leetcode is more important than development? What's your thoughts on Flutter, React Native? I mean, what's your viewpoint on dev stuff? Yeah, so like, you should do it, right? That's like, you should do some, right? You shouldn't just solely do Leetcode. You know, over time it'll just be, you just have to do more of it, more practice of Leetcode, more dev stuff, and then, you know, you'll be fine when it comes to like technical interviews or like passing the resume screening. The thing is, you know, you can't just solely, you have to balance things out. You can't just solely do Leetcode questions only, because it'll just mean you're almost even just wasting your time, because you're only doing Leetcode problems without really seeing the bigger picture of, say, what is involved in in development of anything special. Now, it doesn't have to be anything special, but you know, just having the experience, having the exposure of learning in a dev environment, like building your own project, or even being part of a startup for a bit of time, like those are all still valuable pieces of information that even to me, you know, I could bring up in, say, technical interviews. Like, you know, that's one benefit of having experiences related to dev stuff. You know, that means maybe starting a startup yourself, or trying to find a group of people who are doing a startup and just being a part of the startup culture in a sense. But to be honest, I don't think you really need to worry too much, even for the startup stuff. I had been lucky enough to really want to spend time doing this startup stuff for a bit, which happened like earlier this year, late last year. And you know, I did that for a bit of time until uni started up again for my masters, in which case I just stopped doing the startup stuff. I told the other guys at the startup that I wouldn't do much more, and I would come back after my masters. But turns out the company already fell over, so there's yeah, anyway, doesn't matter. But you know, say like actually Flutter and React Native, right? I've done some React, I've done some Flutter stuff, just like really rudimentary stuff. But you know, if you want to build a mobile app, go for it. You know, just if you have something in mind, do it. Just do it. I haven't really dealt with much mobile dev though, personally. Also, sometimes I also get confused, like which projects to build for portfolio. Also, do you think that YouTube coding space is kind of noisy, everybody talking a lot of different stuff? I do agree with that. So the only people that I watch on YouTube relating to tech stuff is EO, something like t.gg or whatever, t3.gg, I think that's his brand or whatever. But I watch him for web dev stuff. You know, I watch the Primogen for anything general knowledge, I guess, for a techie, right? So he's pretty good. But I wouldn't watch anything beyond that. I wouldn't watch some random guy who got into Amazon and is telling you the 5 steps that it takes to get into Amazon. Or I wouldn't be watching these videos that have like really shitty hooks. Like, by the end of this video, you'll be able to ace your technical interviews. I wouldn't be watching any of that. Because that's all just like noise, yeah, to me at least. You're better off learning from Reddit than YouTube videos from those guys. Now I'm not naming who because I don't even know who's in that space. So I don't even care. Right? But yeah, I agree. YouTube coding space is kind of noisy. But in terms of which projects you should build for, the thing is, it's really up to you. Anything you want to build, you should just do it. For me, you know, that was this scheduler app, right? I want to build something, even if it's done a million times, right? A to-do list app, done a million times, yet I still want to do it because I truly believe that I can do it well, but also help me maintain a level of, I guess standards for myself in terms of what I want my own app to be like, right? So I like to have my apps tidy. So I want to make this one really tidy. Following the best practices from the guy who originally made the tech stack. You know, that's the stuff that I want to follow. That's the stuff I want to learn, you know, through copying. So that's why I do what I did, just, you know, maybe an hour ago when I was doing the scheduler development then. Yeah, Nuffy, you know exactly what I'm talking about. That's it. Literally, like, build something, yeah, that you really like. Because for me, you know, I wanted to build an app that solves my particular problem of not being able to see my tasks beyond just the day-to-day, beyond just, say, the next day. Right? Like, look, if you look at things, has upcoming, but they're not in any way really visualized well, right? It's just a list that appends onto another list that has another list for each of the days going forward, but what if you make this into a grid-like form, right? Just like a calendar, right? Just like a calendar, but for your to-dos. You know, there's apps out there that do this already, like fuck, I know the name. Motion is the name, right? There's Motion, but I don't want to be like Motion in the sense that I don't want to be a paid app and making a subscription like Motion, right? I hate that thought of having subscriptions and being dependent on a SaaS. Right? I'd rather host my own shit. And that's part of my belief system. That's part of the reason why I want to build this app also. So that other people have the freedom, not like what you would have in Motion if you used Motion. Anyway. All good arc shit. Okay, so here's the thing. I'm gonna look at, since I'm taking a while just to walk through this, I'm gonna just do what he's done here. So the equations that he builds out Alright. Cool, so that's that. Hmm. Jamil, so when are you starting at Amazon? I'll be starting early December, and I'll be moving late November. So yeah, it's coming up literally in a month. Wish you good luck. It's really soon. Yeah. Thanks, man. I appreciate it. You know, I might make like I don't know, a day in life video or something. Something. Say something. During that time, I'll probably be streaming less. It's likely that I will be. But maybe I'll still do the daily Leetcode, you know? Maybe even more daily, more consistent. An hour each time, maybe an hour stream each time, you know? Maybe that's something I'll do. Feel like I should have enough time to do that every day when I'm in Sydney. Alright, I'm gonna get some water, I'll be right back. Are you going to do research in your masters? Don't know what it's called in Australia, but usually there are 2 paths for MCS, one with research and one without. Yeah. So currently for me, that is, I'm doing coursework masters, but there is a research component that I can choose to do. Ideally, I want to do it in the case that, you know, I want to do a PhD down the line, which, you know, is always a possibility. And possibly doing a research project as a subject for my masters will be good for me. So for me, I'm doing a masters of coursework though, you know, at the moment, with a research component optional. Ayush, it's literally just lo-fi, lo-fi girl. It's literally just lo-fi girl. Hmm. Hmm. UMCPC. Jane Street. Ah, well, I'm not woman. RIP. Can't apply. Hello, Geary. I'm doing okay, I guess. We will be doing a lecture now though. What about you? Ayush, hello. I mean, how long have you been using Obsidian? Do you prefer more than Notion? Yes, I do prefer Obsidian more than Notion, but Obsidian has its use cases as well. I've been using Obsidian on and off, but until recently, I've been using it more often, especially this semester. In the previous semesters, I've done it in like a summer semester, but then went back to Notion, and then now I'm back in Obsidian. I've been on and off with Obsidian for a while, but I think I'm gonna stick with Obsidian for now. Like, there's no intention of switching now. But yeah. Like, I've been using Obsidian maybe since 2020, when I first started. Actually, I can find the first note that I ever took. It was in 2021, January. There's this really nice, so this is going to be a side tangent for a bit, but there's this really good, I guess, group of people, Monash Coding, which I will share. I will go to their place, their profile. They're pretty good. They usually have some fun stuff in terms of reels. You know what I'm saying? I do want to know though, yeah, RIP. Nah, but these guys have like good memes. Super chill. Now Hmm. Hmm. Yo, look at this. Bruh. Wow. So this is a guy doing a background check for a company at Sterling. And he lied on his resume saying that he was at Deloitte. What? That's what you get. That's kind of what you get for lying. Very unprofessional from this guy. Okay. Cool, let's watch a lecture and we'll call it a night after that because by then it'll be dinner and I think we'll be good. So, we'll pause the lo-fi. We'll go back to... Yes, this week's lecture. Okay, and then we're gonna call it a day. It'll be so good. Today has been quite productive for me. So here's the thing, understand one question from game theory, and I did, all right? Which I'm happy about. You know, there's more questions to understand, but for now I'm happy with that. And maybe I'll just move this to clear. And then we'll just finish one more lecture tonight, and then we're calling it a day. Because what did we do? Yeah, quite a bit overall. Not disappointed. Do you want to know when is the peak? Okay. Interesting. Alright, regardless, let's watch this lecture. It'll take some time, but we'll do it anyway. Okay. Alright. I won't be speaking all that much now, but let's try and beat through these lectures. Let's close these. Close this. Alright. Image segmentation. Now, I might just do this, to be honest. do it like that. Nah, I'll do this.
This material is made available to you by or on behalf of the University of Melbourne.
Okay, and I will make this full screen. Make it smaller. Okay, segmentation is classification. I think that's where we're up to now. Never mind, no we're not. Upsampling. UMA, is this course freely available? No, it isn't, unfortunately. Glitch. So what are you primarily learning these days? I can't seem to figure it out, lol. It's just like you're doing everything all at once. Bruh. The thing is, I guess the past few days, you know, I was doing an exam. This is now for another exam coming up. This is actually like, I did exam revision this today just for another one. This is catching up on another exam for a different subject. So yeah, I am kind of, in a sense, all over the place. And I did a little bit of scheduler development as well today, and still have done our Leetcode stuff. So in a sense, we've done like 4 different domains of things today, just on the stream. So definitely, you know, makes sense. But primarily, you know, it is exam revision, primarily. I just updated to Sequoia and it's miles better than the old OS. Firstly, hello discipline, but secondly, fair enough. What was your old OS? Because I feel like it might have been like old. If you hadn't upgraded until recently. Sonoma? Oh, I mean, that would have just been last year's, I think. Maybe was it Ventura? Oh, it was Ventura, I see. Yeah, no, I see. Like, man, Simonov just felt like last year, hey. Well, anyway. Yeah, nice to see you again, Glitch, you know? Thanks for tuning in. Sus. Alright, let's go. We're gonna use our headphones here. Ugh.
Okay, so this set
Okay, that's not connected.
of lectures is all
Oh, fuck. I hate doing this every time. Sorry, that was loud. Damn it! I hate going into the sound settings, man. Did you see the new MacBook Pro M4? I did see headlines. To be honest, I wouldn't mind looking at it now. But no, I'll do it later, I'll do it later, I'll do it later. Give me the synopsis though.
about images input with images as output, where we're trying to say right, 12:05, looks like the thing is going good. Okay, so this set of lectures is all about images input with images as output, where we're trying to say what is at each location of each image. And we have made the case that we should build some kind of encoder-decoder structure in order to do that. So we, on the left-hand side, have some downsampling operations, and on the right-hand side, somehow we're going to build up a high-res image again. So the idea is that we save computation by downsampling, we get to aggregate information from all around the image by downsampling, and then we get to share that information back up as we upsample and then classify each pixel on the output. So the question is, how are we going to do this upsampling? We're going to cover two methods, one of which nobody ever does anymore, but you should know about it. Somebody might do it again. Thank you. So let's actually think about how to upsample. So the simplest thing we could do would be to just stick the numbers in the top left-hand corner and go from and paint them in, leave zeros everywhere else. So that's kind of that gives you a kind of a sparse representation of the low-res thing, and then a conv will fill in the other values after that. So the first more sophisticated method we'll look at is trying to undo the effect of a max pool layer when you downsample. So when we max pool, what we're kind of saying is this feature present in this region or not? If the feature is present, then one of the four values will be big, and we take the max and we say, yes, this feature is present with this strength, at least somewhere in this patch. That's what max pooling is doing. So that's why we use a max, right? It says, we think of each of these things as detecting something or detecting it with some strength, and we say, okay, who detected it the strongest? Right, we'll use that to say, yes, this was present in this location. So we look at these 4 values here and we keep the number 5 because it's the largest. We look at these 4 values here and we keep the number 6 because it's the largest. Here 7 is the largest and here 8 is the largest, which gives us this downsampled max pool. We then do some processing and we want to upsample. So what we want to do really is say, well, this information, this 5 information, that came from here, right? This 8 information came from there, the 7 came from here, and the 6 came from there. So what we're going to do is take our values and send them back to those locations. So every time we have a downsampling, we remember the location of the maximum value in the downsample, such that when we do an up...
Remember... Okay. So 2 times better than M1, 1.3 times better than M3. It also has nano screen, so it's anti-reflective. I see. Just like their iMac. Interesting. I mean, it sounds like the Mac Minis have the most hype around them. But 2 times better than M1. Yeah, alright, fair enough. I mean, that's still pretty good. Even if it's 3 years later. And the M1 itself is still pretty good. Not bad, Apple. Not bad. Not bad at all.
An upsample, we project back to that location. So we save them, pass them to the upsampler. There's a value 1 here after the computation, and that goes to wherever we found the 5. 2 goes to wherever we found the 6. 3 goes to wherever we found the 7, and 4 goes to wherever we found the 8. So it gets scattered around, and they're now, if you like, targeting the locations that we drew, detected the feature at, in order to send the information, if you like, back there when we are classifying. So the idea here is, if we've detected stuff that we end up thinking it's part of the cow, and we found it was cowiest in the bottom, as you see it, bottom right-hand corner, then we are projecting back the information that says that brown color was part of cow, if you like, back into that location so that we make our segmentation more accurate. That's the motivation.
Oh shoot, right, you did say... Wait, no, you didn't tell me that. What? So you bought the M3 Pro. Oh right, you did. Wait, you did. Oh man, I'm forgetting who is who. I'm sorry. I don't know if it was you or someone else that told me that they sold their M1. I think it was someone else. regardless. But cool, right? I mean, still be kind of pretty hyped with the M3 Pro, to be honest. Because, you know, I would buy a Mac any day if I don't already have one. But even with my baseline model, like, I'm happy with it. Yep. Yep, this is your first Mac, good laptop. Yeah, you see, like, good that you got a Mac at the end of the day because, alright, hear me out. We want to be cultured in the different OSs that exist in the world. Eventually we buy a Mac. Eventually we use Windows. Eventually we use Linux. Alright. The big three we will all eventually use at some point. So, it's best to be informed now than never. Good choice.
Motivation behind doing it. In practice, it turns out almost nobody does this anymore, but you need to know and you should know about it. The thing that people do comes by the confusing name of a transposed convolution. And I'll start by saying what a transposed convolution is not. So it is not take the kernel, transpose it, and apply that.
Okay.
But there is a methodology for using the word transpose that we will come to in a few minutes. Okay, so if I have a convnet, I have a 3x3 kernel, I have a stride of 1, which means I'm applying it at adjacent pixel locations, and a padding of 1. That's going to make my output be the same size as my input, because with a 3x3, I'm going to put a row, single row, padding of 1 of zeros around the edge. That means that my kernel centers on the first pixel when I first put it down, and it runs across until it centers on the last pixel. So it keeps my output the same size as my input. When I want to compute this pixel here, I compute it from this window. If I want to compute this pixel, then I move the window across one. So that's a conventional convolutional layer.
Yep.
When we want to downsample, we might have a kernel that's 3x3, a stride of 2 now. So the stride of 2 means we're going to downsample, and a padding of 1. So for the first pixel in the output, that's where the kernel goes. For the second pixel in the output, we are going to move that window across 2 in order to calculate that second value. So I could try indicating its location with the pen. So it will sit there. It's much harder using a mouse instead of the pencil, but anyway. So that's the location for the kernel. So it's moved across 2 pixels because the stride is 2. So transposed convolution is going to kind of undo the effect of a strided convolution. So if stride is bigger than 1, we do some kind of downsampling. So stride of 2 means the filter moves 2 pixels on the input for every 1 pixel on the output, which means that modulo edge effects, the output is going to be half the size of the input. And we regard this as being kind of a learnable downsampling, right? So all the weights in the kernel tell us how to downsample. One of the things you could learn is just bilinear interpolation, right? You could learn averaging. So I could have, for every 4 pixels in the input, I could have 4 values of a quarter, it would average them together, and that would give me the output. That's one possible thing that we could learn, but the kernel could learn to do other things, and that capability may turn out to be useful. So what we want to do is use learnable upsampling. So we're going to move the filter 2 pixels in the output for every pixel in the input. We're still going to call this a stride of 2, but in this case, the stride of 2 applies at the output, not at the input. So this means that the output is going to be twice as big as the input when we do this. So this is, if you like, a stride of a half, but that is a slightly awkward way to think about it. The stride parameter, when you use any of the deep learning frameworks, would be stride of 2, and it applies at the output rather than the input. Sometimes it's called deconvolution. That is unfortunate because that technically means something different, but don't let that worry you. Up convolution is reasonable. Fractionally strided convolution, almost everybody calls it a transposed convolution, and I'll explain why soon. Okay, so how does this work in practice? So I'm going to go in reverse. So I've got this value in the input. What I'm going to do is, rather than say where each output value comes from, I'm going to start projecting input values onto the output grid. So I'm going to start with zeros everywhere, and then I'm going to take my kernel values, 3 by 3 kernel values, multiply by this, and paint them into the output. Now, I don't bother painting these ones because they're in the padding space, but these 4 I add on to the 0, the number I ended up with. So it's the scalar times the kernel weights that end up, the bottom right 4 kernel weights that end up here. Then I move to the next pixel, and I multiply this by the kernel weights, and I add on, so these 2 become the sum of what the blue bit told us and what the orange bit is telling us. And then these 4 here just got values from the orange bit, so we sum them up. Here we are contributing, so this now is the sum of 3 bits. This is just the green bit, this is the sum of 2 bits, blue and green, and then you can guess what finally happens. We paint into here.
We paint a Windows icon.
4 things in the input that contribute to it. This thing has 2 things in the input that contribute to it, and this part here has just 1 piece of the input that contributes to it. Okay, and then, of course, these I didn't want, so I throw them away. So I trim off the padding, and of course, in practice, I never actually bother computing it to get the output that I wanted. Okay, so let's actually do this in 1D.
Okay.
So my output, I'm going to be not using any padding here. So I'm going to take my input, this is my kernel, and this is going to be my output. So I get 5 times 121 in my output, which is going to give me, I'm going to try doing this, it's going to give me, whoops, sorry for my very clumsy drawing, 5, 10, 5 into the output from the 5. And then the 8 is going to give me 8, 16, 8. So this is going to actually be 5 plus 8, which is going to be 13, actually. And then here I would have 16, and here I would have 8. There has to be a better solution, but never mind. So the final result will be 5, 10, 13, 16, 8. 8 from the transposed convolution. Okay, why do we call it that? Because we can actually represent a convolution. I'm going to do it in 1D, but it applies in 2D too. We can represent a convolution as a very inefficient matrix multiplication. So if I take my kernel, which is, what happened there?
I have a sudden urge to do monkey type. Monkey brain, do monkey type. 1. Let's try and aim for 100% accuracy. Not bad. Alright, one more. Last. Not bad. Okay, we'll call it a day on monkey type. No more. Let's resume. Headphones. We'll try and go to half this lecture.
Okay. Right. Good. Okay, sorry, I'll try that again. What I'm going to do is, A is my input, which is this vector A, which is going to be A, B, C, D. I'm going to pad with a couple of zeros. And my kernel is a 3-sized kernel with values x, y, z. Then the output
Yep,
is
I agree.
this matrix times the input as a matrix multiplication. So what I've done is I've taken
I
the
agree.
kernel, put it in the first location to compute the first value of the output. In the second, move it along one, so there's a stride of 1 to calculate the second one. Move it along again to calculate the third one, and moved it along again to calculate the fourth part of the output. So this matrix, you can imagine if my vector is big and my kernel is size 3, that matrix has a band of x, y, z values running diagonally down it and lots of zeros. But we can represent that convolution as a matrix multiplication. So transposed convolution says, imagine taking that matrix and using its transpose. That's where the transpose bit comes in. So we take that kernel, and there it is with all the x, y, z's running vertically because I've transposed it. I'm multiplying it on something the shape of the output, and I get something the shape of the input. Typically, I'm going to then trim the last 2 values. So I'm going to discard that, and I'm going to discard that, and replace them with zeros, or just trim them off. So that's a transpose, that's transposing it. So it goes the other way. It takes... Okay, I'm beginning to think maybe the cable's got a break in it. I should be careful. Okay, so now let's do it with a stride 2 convolution. So now my kernel has, if I jump around over here, it's not going to damage it as much. Now my kernel has the x, y, z values. The stride is 2, so instead of moving it across 1 on the next row, I'm going to move it across 2 positions. There's my input A, B, C, D. There's my 0 padding at each end. When I do this, I get x, y, z onto 0AB, which gives me AY plus BZ, and I get x, y, z onto BCD, which gives me BX, CY, DZ as my output. So that takes my input of 4 values, and it gives me an output of 2 values. So it's downsampling by a factor of 2. Now I can transpose that, and now I have an upsampling operation. So
Shit.
if I have now a vector of 2 values, AB, I can take this matrix, transpose it, and multiply it by AB and get a bunch of values, and I throw this one away, and I throw the 0 away as well, and now I have a 4-value output, which is going to be my upsampling operation. So what I described before about saying you add on the values you take each input value, project onto the output and add them up, that's the same as doing this. And this is why it's called a transposed conv, usually. So you guys use TensorFlow. In TensorFlow,
I see.
in Keras, it's a transpose conv 2D or transpose conv 3D or whatever you want to call
Interesting.
it. That enables you to use stride greater than 1 to do upsampling. Okay, So this is our structure. We can do upsampling now. Typically, we need to do typically in a classifier, you end with a fully connected layer. So if we think about the VGG or AlexNet or any of those things that does classification, at the end there's typically you do a flatten and a dense layer.
Yep.
We did that in assignment 2. How do you do it when we want to do that in parallel for each pixel? Well, instead of flattening, we regard the set of activations at each pixel as the kind of the flattening for that pixel. And we can then treat all of those in parallel by doing a 1-by-1 conv. So this is a stride, kernel size 1-by-1, stride 1 convolution. Actually is just a matrix multiplication separate on the activations at each pixel. And it kind of treats them independently, just like the dense layer does at the end of a classifier. So you often find it, therefore, as the last layer of a fully connected network, and these kernels basically learn functions of the features in the previous layer in a single receptive field that learn to identify what's present. So now we use this negative log loss. So the yi is a one-hot vector that selects the class we're interested in. So yi is equal to 0 except for the I corresponding to the correct class. That sum then actually just selects the class we're interested in. And yi hat is the probability that the network gives to that. So we use a negative log loss, and then we average that over all the pixels. So we compute negative log loss, or cross-entropy loss, as it's often called, over all the pixels. So FCN was the first attempt to do this, I think, and let me just do an experiment. Okay, it's not the table. Okay, we'll just have to put up with it. I'm really sorry. It's actually expensive to go all the way back up to full resolution, so what we often do is stop somewhere short. If we stop a long way short, so this 32S means we're calculating class membership at 1/32 by 1/32 of the resolution. So if the input is, let's say, 256 by 256, this thing becomes 8 by 8. This would be 16 by 16, this would be 32 by 32. As you can see, as we increase the resolution, but also the amount of computation we have to do, the segmentation becomes more detailed. Of course, when we're training the network, we have a ground truth segmentation that's very high resolution. So 8 stride is what often people do use when they do that. So they upsample just the logits at the end before classifying and training each pixel. These are the results. Looks great. Okay, I won't spend a great deal of time on the summary. You can read it as well as me, but this is a quick description of what we've done. Okay, coming on to something that replaced FCN and is...
All right. How many frameworks you know, backend or front end? Backend and front end. Well, let's count. Fast API, Next.js. I don't know if you can count React. Probably not. But those are the main two, right? I've played around with the MERN stack, but not enough to know it well. Okay, and I think that's the extent of it, to be honest. I think that's the extent of it. Fuck shit.
What we use a lot in modern day. So UNet.
So this is a transposed convolution. UNet.
Nets are now used, for example, in modern diffusion networks for generative image creation. It was originally designed for a medical imaging problem, which was an interesting problem because actually this thing was trying to detect thin lines, which were the boundaries of cells, so that they could do cell counting.
Hey, good morning, Shah.
The idea, so it actually has some extra pieces. It's an encoder-decoder structure with some additional features to help it do that. So this is the shape of a UNet, which is why it's called UNet from this picture. You have your input image, which might be one channel if it's grayscale in medical imaging. It would be 3 channels if it's a color image. And you do some convs to, in this case, 64 channels. And then you do a convolutional downsample to half the size. So we started at 572 square. We're now 284 square. We upgrade the number of channels to 128. We do a downsample. We upgrade the number of channels to 256. These are conv-relu operations. We do it again and again. This is a 32 by 32
just do it
image.
so many times over.
In the middle, we have 1,024 channels, lots of channels. And then we do a transposed conv to start working our way back up. Convs, transposed conv, transpose all the way up. Now, that's great, but this becomes a bit of a bottleneck, right? It becomes like an autoencoder in a way.
Sure, yeah.
And this is very low resolution. And we want our output to be high resolution, but it needs to be responsive to the high resolution input image. So in addition to doing this, we take the last layer in each downsample,
Yeah.
in each stage, and we concatenate it on with the upsample.
Ooh,
So we have 512 channels here. This goes up to 512 channels.
interesting.
We add on these 512 channels. It gives us 1,024. And then we do a conv back to 512, another relu, conv back to 512, transposed conv down to 2,
Shah,
5,
what's going
6
on?
channels. We take this one and we concatenate it.
It's a very good
here in the
question.
white box to give us
Just learning about
512
computer
channels
vision.
and so on, which means that I can't reach that far, but right at the top,
Convolutional neural networks.
this final set of layers is getting information right from the beginning. So it's getting information that has been computed at maximum resolution from the input and therefore is informing.
And this is the
high
architecture
resolution output.
of one of those models.
So that's the design of a UNet architecture. We've upsampled, the upsampled feature map on that side is concatenated with whatever we ended up with at the downsampling stage. For that original task, there were just 2 classes, cell or cell boundary. So that's why there were 2 channels in the output if we look back at it, their output here was a two-channel output. And they then did weighted cross-entropy loss because there are almost no edge pixels and there are lots of non-edge pixels, and so you have to say edge pixels are more important. Otherwise, the thing tends to say there are no edges.
Right.
I'm doing really well because there are almost no edges.
Right.
So these are the kinds of results you get. Okay.
So in decoder, the upsampled feature map is concatenated with the original features from the corresponding encoder layer. I could mark this. Literally, it's just like these lines.
Okay, so that's.
And for segmentation, for cell segmentation, UNet uses only two classes. Weighted core temperature loss. Yep. Edge between cells have high weight. Yep.
It's UNet, and again, I'll skip reading the slide.
All right. Right.
Which brings
I'm
us
just gonna split. So. That's an example. UNet fully convolutional neural network for segmentation with some modifications, originally for medical image analysis but commonly used for other segmentation tasks, also used as an encoding decoding network for the tasks like image denoising and image inpainting. Interesting. Image inpainting, I guess that's what's here, right? Image inpainting. And denoising, definitely just something like this from a noisy like this. So okay. Hello, Harsh. Instance segmentation, here we go. Now this is the part where it gets interesting. You also do competitive programming? Nah, not really. I only do like Leetcode problems, just for practice, for technical interviews obviously. But yeah. Just doing it for technical interviews. Nothing more, you know.
To instance segmentation, so far we can label pixels, so we can do this now. What we can't do yet is this. We can't say, all we can say is there's a lot of cow, but we can't say how many cows there are. So this is great for grass because we don't say how many grasses are there, but and there's about to be a slide on stuff and things. So grass is stuff, cows are things. I can count things, I can't count stuff, is the basic description. How do we separate them? Okay, so stuff and things. So things are objects that are countable. Stuff is material, sky, grass.
Which side are you coding for development? I'm doing mainly the front end at the moment. The back end is what I'll be working on after I'm happy with the front end. And the front end will take maybe up until next year, to be honest, if I'm doing this all alone. So, yeah.
Trees, depends on the application. If I'm labeling images, I might just call it all tree. I wonder if it's some kind of gesture interface. Anyway, no, really, my car, I realise, does it. If you hold your hand up like that, it puts the air conditioner up 2 degrees. It's much easier to turn the dial, but that turns it up 2.
Dude,
that turns it down
sidetracked.
2. It works kind of a third of the time. It's bonkers. Whoever thought that was a good idea should be fired. But anyway, maybe something else like that's happening here, so I should avoid waving my arms. Some things can be either, if I'm doing a forestry application, I might actually want to count trees, or if it's an ecological application. So here is the obligatory cartoon. Do you see the stuff, the ice cream, or the things, the spoon? And instance segmentation is focusing on the things, because that's hard. But often, when we're building big systems, we need to deal with stuff too. So in autonomous driving, which is still quite a dominant application, there are things like pedestrians and cars and bicycles and signposts, and then there's stuff like drivable road surface.
I see.
Or indeed building the sky, just as a general label. Okay, so what we're going to do is we're going to extract patches. Almost all systems that do this use bounding boxes. And in fact, often that's where we stop. So we might not label all the cow pixels for cow 1 and cow 2. We might just say there is a cow inside this box and there is a cow inside this other box. And that's what we're going to see. So we're going to do, if we're going to label it, then we can segment subsequently, and there are systems that do that, into individual pixels. So RCNN, region convolutional neural networks, will run through that sequence over the next lecture or so. That will generate bounding boxes. The final one that we'll look at is called mask RCNN, which will give us pixels. Okay, so RCNN, we're going to start at the story at the beginning, is a region-based convolutional neural network.
Region-based convolutional neural network. What a mouthful. Okay, instead of giving each pixel an instance label, extract patches of image that are likely to be separate instances. Do segmentation within each patch. Valid. Commonly used architecture is mask RCNN, or region-based convolutional neural network.
So what we're going to do is build a two-stage architecture. First of all, we're going to find bounding boxes where we think things are. So the job of stage 1 is, where are the things? And the job of stage 2 is, right, give me the information from this bounding box and I will process it on its own and I will tell you what's in it. So the stage 2 is kind of a classifier. Actually, as it happens, we also say, oh, you made your bounding box a bit big. Here is where actually the thing is inside the bounding box that you gave me. So stage 1, regions of interest for further processing. Cover this, it says next week, but that means this week. So what are we going to do? We are going to take patches and then run them through a fully convolutional network to classify the patches and refine the bounding box. And then
It's like a hitbox.
in mask RCNN, we're going to have another bit of network that tells us which pixels belong to each person. So this bounding box, we're going to classify it as a person, and we're going to say, and these are the pixels. And that's the job of this stage here. Okay, so that is a binary segmentation mask, object or background In fact, in mask RCNN, it's per class. So you do two things. You first of all have a classifier network that says, I think this is a person, I think it's a cat, I think it's a dog, over all the classes. And then you have another network that says, if it's a person, these are the person pixels. If it's a cat, these are the cat pixels. If it's a dog, these are the dog pixels. And then when you apply the loss, you say, right, yes, it is a dog, and these are the pixels, so you get a loss on the classifier network, and then you go just to that plane of the mask segmentation network, and you say, and these are the pixels, and you train just that output. But of course, that mini network has lots of shared weights between all those outputs.
Okay.
Right. This is what it looks like. So this is mask RCNN in action. It generates really quite high fidelity results. So I can get the elephant and all the people sitting on the elephant, the backpack, the umbrella, the people, whatever it is. And of course, people then, if I recall, hang on. That was not meant to happen. I think this is a video. Yes, good. Sorry, I had it still in pen mode. So this is, you can see things blink in and out of existence, right? And that's because there's no time continuity in the processing here. So this is just processing each frame of the video separately, and it's completely blind to what came before and of course, and also to what comes afterwards. But it's capable of finding bounding boxes and detecting things most of the time. There are all sorts of technologies that say the person at time is this person at time t is this person at time t plus 1. This person that we missed at time t plus 1, actually we'll go back and find them. There's a sort of a bunch of research and activity in that area. Great, good, okay. And again, we can do some instance segmentation. We'll cover exactly how this works to detect bounding boxes and classify them. So we can...
Instance segmentation gives separate labels to each instances of a class, not just class labels. Generally only applies to countable thing classes. Typically methods detect object patches, then do binary segmentation within the patch. Segmentation can be approached in various ways, clustering graph-based methods versus pixel classification with FCNs, fully convolutional networks, fully connected networks. This advantage tends to be worse at capturing precise boundary details. It's good.
do this covering all of segmentation. So if you think back, we did just chop things up by color, cluster by XY RGB or LAB, but then we moved to neural networks to do the same thing. These things massively outperform, and in fact, of course, we get class labels as well. Then there's a question about transfer learning. So we can train our fully connected network on the classes we care about, and then you come along with your problem, and there are different classes we care about. Just dealt with an example of this recently, working with Telstra to identify street poles that are suitable for 5G installations. And the thing that they care about is whether the pole has a transformer on it. Does it have high voltage wires as well as low voltage wires? Does it have a street light on it? Is it just a street light? As it turns out, that's bad, because street lights are only powered at night, and they want to parasite off the power. I mean, with money, they pay, but they want to be able to use the existing power supply. It's just a street light turns out to be bad because they're not powered all the time. So we use something that can classify stuff in using something like RCNN, actually it was YOLO, but it's been trained on a bunch of classes. Now we have to train it to identify the things that we want it to find. And so the question is, how well does it generalize and is it able to adapt to, transfer its learning to a set of classes that are outside its training set? Cool.
Cool. I'll stop it here for now, because I think I'll call it a day. I've studied quite a bit. And we'll say this is left to complete for tomorrow, or maybe tonight if I am feeling it. So I think that's it, guys. We'll call it a day. I'll have dinner in just a moment, and yeah, thanks for joining in. Thanks for sticking along. I'll see you guys probably tomorrow. Alright. So peace.